Hey, hi everyone. Hope everyone is doing well. So today we'll touch upon probably one of the concepts in system design that I would rate in the top five system design components. Load balancers, and as the name suggests, this is like fairly straightforward to understand. But there are some details I think from a system design interview perspective that you should definitely keep in mind. So I think load balancers have been around for quite a few, I would say years. Uh, Earlier form of load balancers were typically focused on the hardware side, where you would manage, I think, load from different layers through hardware components. But now software being so advanced, it has the capabilities to mimic the capabilities of that hardware load balancer and provide you as a software layer, right? So typically the design of a load balancer, you can explain in a system design interview in the following manner: that there would be a lot of applications either to your computer or mobile apps, and those are generating basically good number of requests, right? And at any point of time, your servers, like, which is the end system, which is basically going to receive these requests, will have limited capability, right? So what do load balancers usually help with is that give a systematic way, or a systematic process in which I think you can sequentially or unsequentially as well handle these requests, right? So why are load balancers required? As we mentioned, that these distribute the traffic evenly across these servers. So servers is like your last probably stage that you can think of. Load balancers are these cute tiny little boxes that are actually distributing the traffic that is coming through internet, right? um, I think it also improves the reliability of the application. So for example, if your application is a login page, right, and then 1000, 2000, whatever million users start logging in, right, you have to ensure that that login page doesn't go down, right? I mean, it has to have a response when users are entering the information, right? So that leads to a good customer or user experience. Generally, I mean, load balancers also help you with increasing the capacity of application. So uh, earlier, let's say for example, you were supporting 1000 users, now you have scaled those to 10,000 users. If you put in load balancers, you don't have to change a lot on the server side. You can still keep maybe one or two, whatever, like number of servers that you had, and then still support, because you have invested in the load balancing layer, right? So there are quite a few matrices that are actually used, and typically I think folks from computer science will relate to it, because these are from a product management perspective, these uh, matrices are good to know. But unless these translate, for example, into user side, right, which is your final customer using your application, you should probably keep them in mind, not worry too much about what is increasing throughput means. You should definitely know what a throughput is. But then designing load balancer, uh, when you say that you're going to use load balancer in a certain layer, it is kind of understood that you are either trying to reduce server response times or trying to increase the throughput, or ensuring, I think, what availability and reliability thresholds you are looking at, right? uh, in general, I think server response times are like kind of very, I would say, intuitive. I think what most companies actually that I have worked on at enterprise level, I think, usually look at these numbers: high availability and reliability. And availability basically means the percentage of time system is able to perform on its task, right? So you might have seen that table of 99.99, 99.999, 99.99999, right? Those are the numbers. As you increase the duration, your availability of the system basically has to keep on increasing, right? So that the unavailability, right, keeps on reducing when you are actually increasing your number of requests, correct? So those numbers, I think, you can definitely Google and find out. I'm not going to spend a lot of time, but availability and reliability are both matrices that are probably brought a lot, like. So again, reliability is probability of the system performing correctly. Again, higher the probability, the better you can define the system in terms of its reliableness, right? You want to design systems that are reliable, right? So, both of these matrices are discussed, I would say, in engineering discussions when product sits, when these are like, first time design, right? Or you're trying to improve the design of the system when you're bringing in more users, right? So, those times I think you should definitely have this server performance checks. I think sort of health checks. I think that you put in place to see, like, I think if some servers are being overutilized, underutilized, right? And addition or removal of servers. I think, yeah, I mean, some servers might not being used, like in some geographic locations across pods, for example, right? I mean, there you might just remove certain servers and bring in more additional servers where the loads are like high, right? So these are some of the matrices and system impacts of load balancer. uh, I think one other thing that you have to keep in mind is the algorithms. I'll come to this load balancer part because those are like mostly very straightforward, uh, standard textbook definitions. But I think load balancing algorithms, I mean, usually in system design, you might get asked, okay, so you're designing this. Uh, you might have to put some thought around what are the kind of algorithms that are available, one, and then which one do you think, I think, mostly might be used. I'll cover which ones I have seen being used, right, and then be at least familiar with what algorithms are available, right? So round robin, name suggests sequential rotation manner. All the requests that are coming in, you put in a round robin fashion, and then you just assign it to the servers. Weighted round robin, again, you might have some configuration of the servers, right? So for example, this server might be holding 256 gigabytes of RAM, this must 512, this might be even more, right? So you have to keep the configuration of the server in mind by assigning it a weight, right? And then you assign a round robin weighted algorithm, right? Least connected, okay, directs basically request to server that is, in 1 hour, for example, this is a 20, this is a 40, whatever, 60, then you probably direct this to request more to this, right? Least response time, again, this is comprised of the configuration. Why a certain server is able to respond in very quick period of time might be because the configuration is very high end, right? So if that is the case, then you would want that to be continued. But that also means that you have to keep a check of these two parameters that we talked about, right? These two metrics. When you're increasing the load on a particular server, then you have to make sure that the availability of the system is not going down, and the probability of the system to give you the correct, right, data back, right, that also stays within thresholds, right? uh, I think IP hash, client IP address, basically, that you get, right? You use some hash function and then you transform it, and then servers basically get the request. One, I think, call out that I would take a time, in industry, in specifically, I think uh, I have seen some form of weighted round robin and IP hashes being used very frequently. I'm not saying that the other ones are not used, but IP hashes, for example, servers, we can take an example of Uber, for example, right? Uber ride requests that are being generated from a particular, let's say, set of pin codes, and let's say those are dense office area pin codes, right? Where you're constantly getting requests, for cabs or whatever, autos, right? Those areas, for example, your hash function has to take those areas into account and direct those in such a manner that eventually, no matter where you send the request to, you're basically getting back the response uh, pretty quick, like within the thresholds again, right? So hash functions, if you, for example, use a round robin here, the problem is that some persons in the office, for example, right, where they're requesting the cabs and whatnot, right, or metro stations, whatever. Some folks are going to get better response. Some are going to get absolutely, like, useless response, right? That is a problem with sequential rotational, like, manner, wherein like the first person who would have requested, the second person who would have requested would probably get the best response, and then the person who hasn't had any, like, chance to put in a request, like the last person, second last, whatever, right? Those folks are not going to get good responses, right? The IP hash basically is going to look at your the hash function will take care of, this is an office area set of pin codes where the requests are being originated from, and it's going to direct that in such a manner that, let's say in this case, maybe it will direct it to all the three servers. That is how you've designed your hash function, right? So you're going to get a response which is equally good for, all your users, right? uh, Now coming to, I think, the last part of this, like, load balancers, is the type of load balancers. uh, Not seen, I think, much of L4, I think, because it's primarily on the networking layer. I definitely have had some interactions around L7 application load balancers, where there have been discussions around sessions and cookies, user sessions and cookies to be, like, managed. Uh, I think, yeah. I mean, if there is a need to, like, go deeper into any of these topics, feel free to leave a comment. Multi-site or global load balancers basically combine both L4 and L7 across various data centers, right? I think from a system design perspective, always try to keep in mind the trade-offs when you're choosing load balancing algorithms, and what are the matrices that you're trying to, like, basically improve, right? Or keep pretty much the same, right? So if you're saying that I'm trying to make the availability 99.99, and I'm going to increase my user base from whatever 10K to 1 million, then for those 1 million users also the availability needs to be 99.999 whatever, right? Then what are the possible algorithms that you can think of? Again, I'll depend on your overall system as well, the other parts of it, but in general, I think these two parts, right? I mean, matrices and balancing algorithms, I think, will help you answer, I think, some of the question. Uh, I think till now we have covered basically, I would say, the three most important concepts or the system parts in any system design. Load balancers. This video we have covered message queues, we have covered caches. I do plan to cover, I think, APIs next. I also have plans to, like, look into database architectures. But I think I'll probably also shift gears to actually bring in more real world examples now, and actually see how are these, like, connecting. So we might pick a, let's say, an example of how do you design a rate limiter, or how do you design a Craigslist, for example. We have covered, I think, Google Photos in the past, but I'll try to revisit, I think, system design interviews from the perspective of whatever we have learned so far, and try to, like, make it more complete, by covering these components. So hopefully, I think this was useful. If you found this useful, please like and subscribe to my channel. Thank you.